The most common application of derivatives is really to use differentiation to find slope. And if we know the slope of a line, we are also able to obtain the equation of the tangent lines. So differentiating a function f(x) enables us to obtain the slope of a graph. So for example, if I'm given a function f(x), so I can write f(x) as y, and it's equals to x cubed minus 2x plus 1. If I am to differentiate to obtain df over dx, alternatively I can write it as f prime x. This expression after differentiating f gives me 3x squared minus 2, and this expression allows us to find the slope at any point on that graph f. So if you'd like to see some animation or explore a little bit more about the slopes of cubic functions, you can take a look at this link provided. In this example 1, we are asked to find the equation of a line tangent to a curve given by y equals to 1/3 x cubed minus 5x. And they give us a specific point given by coordinate 3, -6. So we have learned that in order to find the slope of any line or any part of the graph y, we need to differentiate and obtain dy dx. So let's do that. So we differentiate y, and this would then give us the expression to find the slope at any point. So let's simplify it first, and dy dx is now given by x squared minus 5. And if we want to find the specific slope at the coordinate point 3, -6, what we do is to substitute the x coordinate. And let's call the specific slope at that point m. So we evaluate m to be equals to 4. And thus, to find equation of a tangent line is a straight line that passes through the point 3, -6, and it touches the curve y. So let's use the straight line equation. So right now we have the following information. We know the x and y coordinate as well as the slope at that specific point. So then we can use it to find the y-intercept of the straight line, given by c equals to -18, and thus we answer the question with the equation of a tangent line given by y equals to 4x minus 18. Let's look at what this really means graphically. So the equation that we are looking for, or we had found in fact, is just this green line that is drawn for you. And that line is what we call a tangent line, and it's given by the equation y equals to 4x minus 18. Another example, so example 2 is almost similar, but let's look at it again. We are given now a different function, a different y expression, and this time round we are not given a coordinate, but in fact we are just given the x coordinate, not the y coordinate. So nevertheless, let's rewrite this, and obviously to find the slope of any curve, we need to obtain the dy dx. So using the power rule and chain rule, we obtain dy over dx and simplify it. So obviously, because we want the slope at a specific point, so I'm going to substitute the specific x equals to √3 into my dy dx to obtain the value of the slope at that point, which is given by a -√3 over 8. And if you want to find any equation of a straight line, we use this expression y equals to mx plus c, which is our general form of a straight line. And so far we have the coordinate x and the slope at that point, but we're missing the y value, so we can actually use the y coordinate of that point, because that point is the point that passes through the tangent line, isn't it? So we find y equals to half. So using all the information that we have, we can now obtain the value of c, which is the y-intercept of this tangent line, and we realized it's 7/8, and we put it back into the equation of our tangent line and express it as follows, as y equals to negative root 3/8x plus 7/8. And let's see how it really looks like graphically. So we plot the curve, which is given by the red curve, and the tangent line is drawn in green, and that passes through x equals to root 3. So that's the equation that we had been looking for.